Vanakkam. Now we are going to solve one problem from GATE EC 2023 question paper, and this is based on nodal analysis. Okay, so in the circuit shown below, the current I flowing through 200 ohm resistor is dash milliamps rounded off to 2 decimal places. So we have to find out the current which is flowing through this particular resistor of 200 ohms. Okay, so it is termed as I. Okay, let's proceed. So this is a circuit diagram which will mark the nodes, and this can be taken as node number 1 and this is node 2, and here V1 potential is assigned and for this V2 is assigned, and this is the reference node and it is at 0 potential. And here we mark the current I1 flowing through this path, and here I2 current is flowing, and here this I3 current is flowing, and this is I4 current, and this is I5 current. Okay, so we marked all the currents. What is the potential at this point? So that is V1 minus 2 volts, because when you want to find out the current flowing through that, this is essential. So since it is nodal analysis, we are going to apply KCL, Kirchoff's current law. So in a particular node, summation of entering currents is equal to summation of the leaving currents. So here if we take node 1, in this node this I1 current is entering, I2 is entering, this I4 is also entering, but I3 and I5 are leaving. Okay, so we'll write the equation I1 plus I2 plus I4, that is equal to I3 plus I5. So now we apply Ohm's law. So here I1 is flowing from the 0 potential to this V1 minus V2 in this path. Okay, so it is 0 minus of this V1 minus 2 divided by the resistance is 2K. So it is 2 into 10 power 3 plus I2 is flowing from this 0 to this V1 potential. So it is 0 minus V1 divided by 2 into 10 power 3 plus I4 is 1 amps current that is given in the circuit itself. So it is 1 into 10 power minus 3, that is equal to I3 is, it is flowing from this point to this point, that is V1 to V2. Okay, so it is V1 minus V2 divided by 1 into 10 power 3, that is kilo ohm. Okay, plus then I4 is 1 milliamps current, so it is 1 into 10 power minus 3. So taking common denominator as 2 into 10 power 3, we get this as minus V1 plus 2. This is again minus of minus, this is minus V1, then plus this is 2 into 10 power 3 multiplied by 1 into 10 power minus 3. Okay, so that is equal to, on the side here also if I take the common denominator as 2 into 10 power 3, then here it is 2 times V1 minus V2 plus here it is 2 into 10 power 3 multiplied by 1 into 10 power minus 3. Okay, so these two we can cancel out, and here also we can cancel out these things. So here we have this as minus 2V1 plus 4, that is equal to 2V1 minus 2V2 plus 2, isn't it? 2V1 minus 2V2 plus 2 minus 2V1, then minus 2V1 plus 2V2 when you bring the terms here, and this is 2 minus 4. Okay, so it is minus 4V1 plus 2V2, that is equal to minus 2. So if you divide them all by 2, We get this as minus 2v1 plus v2, that is equal to minus 1. So this is our first equation. Now we apply KCL at node 2. So here the incoming currents are I3 and I5, and this I current is leaving current, isn't it? So we can write the equation as incoming currents or I3 and I5. So sum of the incoming currents, that is equal to leaving current I. So this I3 can be written as V1 minus V2 divided by 1 kilo ohm plus I5 is 1 milliamps. So it is 10 power minus 3, that is equal to I. I is V2 minus 0 potential divided by this 200 ohms. So if I take the common denominator here as 1 into 10 power 3, it is V1 minus V2 plus 1 into 10 power 3 into 1 into 10 power minus 3. Okay, so that is equal to, here also I would like to take this as the common denominator, then it is 5 times that V2. So we can cancel out here, these two get cancelled, so that it is V1 minus V2 plus 1, that is equal to 5V2. We can write this as V1 minus V2 minus 5V2, that is equal to minus 1. So it is V1 minus 6V2, that is equal to minus 1. So this is our second equation. So multiplying this second equation by 2, we get this as 2V1 minus 12V2, that is equal to minus 2. Let me take this as equation 2 dash. Okay, then we add this first equation and the second dash. Okay, so that we get this as minus 11V2, that is equal to minus 3. That means V2 is equal to 3 by 11 volts. So from this we can calculate I, because I is, it is V2 potential divided by 200 ohms. Okay, so that is equal to 3 divided by 11, it is divided by 200, means that is multiplied by 200 here. Okay, so this is equal to 1.3636 milliamps, but in the question we are asked to round it off to 2 decimal places, so the answer for I is 1.36 milliamps. So this is our answer. Thank you.